and my project is on Pascal's triangle. Pascal's triangle is a geometric arrangement of numbers in a triangle where entries, or elements, are the sum of the two directly above them. Encompassing a broad spectrum of mathematics, it has connections in combinatorics and number theory, and applications in problem solving. It is named after French mathematician Blaise Pascal, who explored many of his properties during the 1600s. The triangle, however, was discovered independently by the Persians and Chinese hundreds of years prior to its introduction to Europe. From an apex and exterior of ones, new elements are derived in terms of previous ones, or recursively. The 2 in row 2 is the sum of the two ones above it, while the elements in row 3, for example, are given by 1 plus 2 equals 3 and 2 plus 1 equals 3. Further down in the triangle, 126 is the sum of 56 and 70, and 28 plus 56 gives 84. As direct results of this construction, we make some subtle structural observations. Firstly, the triangle exhibits a vertical left-right symmetry. As an example, we focus on the symmetrical arrangement of elements in row 7. 1, 7, 21, 35. Secondly, we notice if a row number is prime, then all the elements in row n, excluding ones, are divisible by this prime. 7 is a prime. In row 7, 7, 21, and 35, but not the ones, are divisible by 7. A column in the triangle may be identified as a series of numbers running diagonally from a one line of the triangle sides. Briefly, about the naming conventions associated with the triangle, the first row is termed row 0, first entry element 0, and first column 0. The most notable property of Pascal's triangle concerns binomial expansion. To expand a binomial is to evaluate an expression of the form x plus y to the n. In an elementary manner, one might do so with tedious multiplication. The binomial theorem describes the form of an expansion in a compact sigma notation, therefore simplifying the process of constructing one. It states x plus y to the n is equal to the sum from k equals 0 to n of n choose k, x to the k, y to the n minus k. Meaning, as k, the term number increases from 0 to n, exponents of x increase, and y exponents decrease. Coefficients here are denoted by the n choose k combinatorial identity. From a branch of mathematics called combinatorics, this symbol represents the number of ways to choose k objects from among a larger set of n. Its value is given by the formula n factorial over k factorial times n minus k factorial, where factorial means we multiply a number by all the positive integers smaller than it. Pascal's triangle further simplifies the process of expanding a binomial by providing one with these coefficients. More specifically, if we define an element in the triangle by its location in row n, position k, then we observe the value of an element is the exact value of an n choose k identity. The integration of this relationship into the construction of an expansion is shown by the examples here. X plus y squared has an expansion x squared plus 2xy plus y squared with respective coefficients 1, 2, 1. In row 2 of the triangle, these are the three elements. Similarly, x plus y cubed has an expansion x cubed plus 3x squared y plus 3xy squared plus y cubed with coefficients 1, 3, 3, and 1, the exact elements in row 3 of the triangle. By this inequality, we can determine relationships about with elements in the triangle based on properties of coefficients or the reverse. This is illustrated in 4 instances.